In the previous lesson, we analyzed in detail how a simple multi-layer neural network works. Let's recall that it analyzed data based on the current moment and gave a response. For example, if it's windy and raining outside, the network would recommend taking a coat. However, the neural network's decision did not consider the possibility of weather changes over time. In reality, we often deal with predicting the future based on our prior experience. One can argue that a person's previous experience consists of various parts. For example, our breathing or jumping at sudden sounds are our reflexes. This is also a kind of prior experience. The experience of our ancestors who walked on two legs, were hunchbacked, swam, or crawled. It has been passed down to us, not in the form of information, but in the structure of our bodies, our brains. Our entire organism embodies prior experience. Another form of retaining past experience is long-term memory. We remember that 2 + 2 = 4, the unpleasant wart resembling Putin on our math teacher's nose, and many other equally useful things in life. But long-term memory can be conditionally divided into two categories. Let's call them memory of static facts and memory of dynamic facts, or memory of objects and memory of processes. For example, remembering that a tomato is red is memory of an object. We remember the fact that if a tomato is red, it can be eaten. And remembering how a green tomato appears from the flower, grows, and turns red is memory of a process. Conclusions about whether we can eat this tomato yet or not will appear at some point in this process. Another form of memory is short-term memory. We walk down the street and see that a park bench is freshly painted. This important fact at the moment will be forgotten after a few hours. The memory of it is not vivid or useful to us, so the brain will destroy it after a few minutes. Of course, we could have not noticed the paint, sit on that bench and stick to it. In that case, memories of how the police spent several hours peeling us off the bench planks would occupy a prominent place in our brain next to the teacher's wart. Because they would definitely be vivid. Back to the neural network. Our wearable neural network has been trained to draw conclusions based on long-term memory of static facts. The neural network would recommend taking a coat even when the last drops of a storm are falling from the sky. It did not see the process. It is categorical. There are drops, put on a coat. But for people, it is more important to make decisions by predicting processes, not static data. Because a tomato can remain red even after lying for a month, but it certainly will not be edible. So how do we make a neural network remember the process? There are several ways. One of them, use our neural network from the previous lesson. Imagine we have temperature data. The temperature was measured hourly for a year. We create a neural network with 10 inputs and 1 output. We supply 10 temperature values from the previous hours to the inputs, starting from the beginning of the measurements, and we provide the temperature of the next hour as an example of the result. Here, the concept of a data window is important. This window allows the neural network to see only a limited amount of information. In our case, the temperature of the last 10 hours. At first, we look at the data from the first 10 hours of the measurement archive. That's our first window. Based on this data, the network tries to predict the temperature in the 11th hour. Then we shift the window one step forward Now it covers data from the 2nd to the 11th hour, and the network predicts the temperature in the 12th hour. We continue this process until we analyze all the data from the year. This method helps the neural network learn temperature changes, taking into account previous measurements and detecting patterns. Now the trained network will take into account the memory of dynamic temperature changes and make appropriate forecasts. The disadvantage of this approach is that each time we have to pass a window to the neural network. And sometimes for a quality forecast, it is necessary to pass a very large window. To do away with the window, it is necessary for the neural network structure to have short-term memory, so that data can be passed step by step, and the neural network remembers information about previous steps. This can be done by slightly changing the structure of the basic neuron, which the neural network is made of. Let's feed it input data from its own output from the previous step. This means that we make the first step in learning, get data at the neuron's output, and remember it. And on the next step, these data again enter the neuron along with other input data. We create a neural network from such new neurons. Now there is a state in the neural network that depends on previous data. A kind of short-term memory. Now temperature data can be passed not by window, but step by step. The network will react, remembering the previous steps. Networks that are created to predict processes changing over time are called recursive. They are the basis of many well-known neural networks, including ChatGPT. Yes, ChatGPT is a recursive network that predicts the construction of human speech sentences. And a simple or recursive network must give an answer when data flows in. So in ChatGPT, there is always an answer to every question. The final word always belongs to ChatGPT. It reminds me of my wife. She also always has the last word. But that's a topic for another video. No, not about the wife, but about language models and ChatGPT. I promise to pick the most interesting facts about them for you, so subscribe to the channel to not miss anything.